In software development, a breakpoint is an intentional stopping or pausing place in a program, put in place for debugging purposes. It is also sometimes simply referred to as a pause. More generally, a breakpoint is a means of acquiring knowledge about a program during its execution. During the interruption, the programmer inspects the test environment to find out whether the program is functioning as expected. In practice, a breakpoint consists of one or more conditions that determine when a program's execution should be interrupted. Breakpoint conditions. Breakpoints are most commonly used to interrupt a running program immediately before the execution of a programmer's specified instruction. This is often referred to as an instruction breakpoint. Other kinds of conditions can also be used, such as the reading, writing, or modification of a specific location in an area of memory. This is often referred to as a conditional breakpoint, a data breakpoint, or a watch point. Breakpoints can also be used to interrupt execution at a particular time, upon a keystroke, etc. Inspection tools. When a breakpoint is hit, various tools are used to inspect the state of the program or alter it. Stack trace of each thread may be used to see the chain of function calls that led to the paused instruction. A list of watches allows one to view the values of selected variables and expressions. There may also be tools to show the contents of registers, loaded program modules and other information. Implementations. Hardware. Many processors include hardware support for breakpoints. As an example, the x86 instruction set architecture provides hardware support for breakpoints with its x86 debug registers. Such hardware may include limitations, for example not allowing breakpoints on instructions located in branch delay slots. This kind of limitation is imposed by the microarchitecture of the processor and varies from processor to processor. Software. Without hardware support, debuggers have to implement breakpoints in software. For instruction breakpoints, this is a comparatively simple task of replacing the instruction at the location of the breakpoint by either an instruction that calls the debugger directly or an invalid instruction that causes a deliberate program interrupt. This technique may be more difficult to implement in multitasking systems using shared program storage. Also, if the program resides in protected memory, overwriting of instructions may be prevented. Alternatively, an instruction set simulator can implement unconditional or conditional breakpoints, by simply embedding the appropriate condition tests within its own normal program cycle, that also naturally allows non-invasive breakpoints. Interpreted languages can effectively use the same concept as above in their program cycle. Instrumenting all the source code with additional source statements that issue a function that invokes an internal or external debug subroutine, is yet another common approach. This method increases the binary size and might adversely affect normal memory allocation and exception handlers. Debug options exist on some compilers to implement this technique semi-transparently. Some debuggers allow registers or program variables in memory to be modified before resuming, effectively allowing the introduction of hand-coded temporary assignments for test purposes. Similarly, program instructions can often be skipped to determine the effect of changes to the program logic, enabling questions about program execution to be answered in a direct way. In many cases it may be the only practical method of testing obscure event-driven error subroutines that rarely, if ever, get executed, without the added risk of leaving temporary source changes. Manually changing the resume location within a pause program can be used to enter an otherwise rarely executed section of code. Implementing data breakpoints in software, however, can greatly reduce the performance of the application being debugged, since it is using additional resources on the same processor. However, this is normally acceptable during testing and the amount of information available from the debugger is not restricted by limitations of debug data known to the hardware. For instance, a software implementation can collect logical path data at program instruction level to considerably augment what might be stored by the particular hardware platform for inspection. The instruction set simulation method considerably reduces the overhead, compared to the instruction replacement method, also reducing cache misses. Some programming language implementations expose their debugging functions for use by other programs. For example, some Fortran dialects have an AT statement, which was originally intended to act as an instruction breakpoint. Python implements a debugger accessible from a Python program. These facilities can be and are abused to act like the come-from statement. History machine breakpoints. Early mainframe computers, such as the IBM/360, had console switches dials that allowed breakpoints at specific instruction storage addresses and provided single-cycle operation, permitting the contents of registers and memory to be observed directly on console lights. The advent of multitasking limited the use of this option since the entire machine was halted. Non-interactive breakpoints. Programmers have used machine code patches to implement single destructive breakpoints to cause a core dump since the early days of computers. The core dump provided the state of the registers and memory at the exact moment of the deliberate crash. Interactive breakpoints. The advent of teletypewriter consoles in the 1960s allowed more interactive command line debugging capabilities, but it was not until the early 1970s and the arrival of ubiquitous video monitors connected to mainframes that fully interactive, full-screen debugging in multitasking environments became a reality. This also permitted step-by-step program execution in a true program animation manner with optional register and memory alterations simultaneously displayed. Initially, this type of animation was at the level of disassembled or decompiled machine code, but later advanced to HLL source-level animation. See also, come from, IBM Oliver, Program Animation, Simon. References